So we're diving into making transformers even better, those AI models that are already rocking the language world. But what if, and this is where it gets interesting, what if we could make them smarter by teaching them to, well, forget?
Now, that does sound a little counterintuitive, doesn't it? But that's exactly what this research paper is suggesting, that forgetting might be the key.
Right. The paper, it's called Selective Attention Improves Transformers, and it basically says that the way transformers currently handle information, paying attention to every single detail, it's like,
Trying to have a conversation in a room full of, like, shadowing monkeys.
exactly. You can barely hear yourself think. And the paper argues that this traditional attention mechanism, it can actually be a bottleneck.
It can be, yeah. And then the solution, they call it selective attention.
Okay, so unpack that for me. What is selective attention and how does it make AI more efficient?
Well, think about how our own brains work for a second. We don't give equal weight to every single word in a sentence, do we?
Definitely not. Like, I'm pretty sure I've never analyzed the word the in my life.
Exactly. Our brains, they're hardwired to focus on the most important stuff, the stuff that really matters. And selective attention,
Hmm.
it lets transformers do something similar. It's like giving them a mental highlighter, letting them pick out those key words and phrases.
So instead of getting bogged down by every little detail, the AI learns to prioritize just like we do. That's incredible. But this isn't just about making AI think more like us, right? This paper also says it makes AI more efficient.
Oh, absolutely. This new approach, it's called context pruning, and it could actually significantly reduce the memory and processing power that AI needs.
Hold on, wait. So we can make AI faster, more powerful by teaching it to forget.
It does sound a bit paradoxical, but
Yeah.
the researchers actually found that by forgetting that less important information, those transformers could become way more efficient without sacrificing any accuracy.
So it's like, what, cleaning out your mental attic? You get rid of the clutter to make room for what really matters?
That's a great way to put it. And just like a clean attic, context pruning helps those transformers access and process information more effectively.
This whole selective attention thing, it's already blowing my mind, and we're barely getting started. And they put this to the test, right? Like, ran these revamped transformers through some serious language
Oh,
challenges.
yeah, they really put them through the ringer. They tested them on all sorts of tasks, including one called the C4 dataset.
C4, and correct me if I'm wrong, but that's the one that's like insanely huge, like trying to summarize the entire internet,
Not
huge.
far off. C4 is massive, yeah.
Yeah.
Which is why it's such a great way to train and evaluate AI. And what's really wild is that this whole selective attention thing, it actually boosted performance across the board.
Across the board, so different model sizes, different tasks, it just worked.
It just worked, that's pretty compelling when you think about it.
Okay, so it works, but how much faster? How much more efficient are we talking? Like, give me the numbers.
Okay, so in one setup, they found a 16x reduction in memory usage.
Whoa, hold on. 16 times.
16 times. And get this, they kept the same level of accuracy.
So we're talking AI that's potentially 16 times more efficient, using 16 times less energy, and it's not like sacrificing performance to do it.
That's what the research suggests, yeah.
This is huge. This isn't just like a cool trick. This feels like we're uncovering some like fundamental principle of intelligence here.
Right. That's what makes this research so fascinating. And they actually draw a parallel to neuroscience. In the paper, they talk about how our own brains, they use selective attention too,
Yeah.
to filter out distractions, focus on what matters.
So we're not just making AI smarter, we're making it more like us in the process.
It's an interesting thought, isn't it?
It really is. This whole thing with context pruning, though, how much is it really like decluttering your mind? Like, is it basically just setting limits on what the AI can hold on to?
Yeah. That's a great way to think about it. Imagine like your brain is a computer with limited RAM, right? If you've got too many programs open, everything slows to a crawl.
Ugh, tell me about it. Happens to me all the time.
So context pruning is like closing those programs you're not using anymore, freeing up resources.
So instead of trying to remember everything, which, let's be honest, is just not efficient,
No, it's not.
the AI learns to focus its resources on what's important. It's like that saying less is more, but applied to artificial intelligence.
Exactly. And the researchers, they actually experimented with different ways of doing this context pruning, and they found that even with like small memory budget,
Memory budget.
yeah, like giving the AI a set amount of memory it can use, even with small ones, the transformers still performed like really well. They were even experimenting with giving different memory limits to different layers within the transformer, like organizing a bookshelf or something.
Okay, so you might give more memory to, like, the layers dealing with all those complex grammar rules and less to the ones that are just handling, like, simple word associations.
Yeah, exactly. It's
Yeah.
all about like optimizing, making sure the resources are where they need to be.
This is incredible. We're basically doing more with less, smaller memory footprint, but you still get those same amazing results. It's like Marie Kondo for AI. But the paper, it focuses specifically on decoder-only transformers, right?
Mhm.
What about all the other types out there? Like, could this work for them too?
That's a great question. And the researchers, they actually acknowledge that this is just like the first step. They
Oh.
focused on decoder-only models, the kind that are used in like language generation and stuff.
Right.
But there are so many other types of transformers out there. The
Mm.
ones used for like image recognition, decision making, you name it.
So this research, it's not just like a one-off breakthrough, it's a launch pad. Like it could spark a whole wave of new developments in AI.
Absolutely. It's like we've discovered a new element on the periodic table, but for intelligence.
Okay, that's a good one. But it's true because like any new discovery, there's so much we don't know, right? But the potential here, it's undeniable. This idea, selective forgetting, it could fundamentally change how we design AI, how we build it. It's actually giving me chills in a good way.
Got it.
One of the tests they use in the paper, the Hellaswag benchmark, that one's designed to see if AI can actually like understand human-like thinking, right?
Yeah, Hellas Way. It's all about common sense reasoning,
Mm.
being able to like predict what a human would say or do.
Yeah.
It's about more than just recognizing patterns in data. It's about genuine understanding.
And the transformers with selective attention, they like aced it.
They aced it. They were consistently better than the standard transformers.
Yeah.
So, this whole focusing on key information, it might be a crucial step towards AI that doesn't just process language, but actually understands it.
Wow. Because it's one thing to build a machine that can, like, write a grammatically correct sentence, but to create something that actually gets the nuances of how we communicate, the humor, the sarcasm, even.
Right. All those things that make us human.
That's a whole other ballgame.
It really is. And this research, that's what it makes you think about, isn't it? Like bridging that gap between artificial intelligence and how we experience the world.
It really makes you think about how our own brains work, Like, they're so complex, but they're also incredibly efficient.
Oh,
We
absolutely.
can process all this information, learn new things, even write poetry, and we're using, what, about the same amount of power as a light bulb?
It's remarkable, isn't it? And a lot of that efficiency, it comes down to, you guessed it, selective attention.
Just like those transformers we're talking about.
Hmm.
It's almost poetic, don't you think? To make AI more powerful, to make it more like us, we might actually need to teach it to, well, forget.
It's a fascinating paradox, isn't it?
It really is, letting go of the noise and focusing on what truly matters.
And that's where things get really interesting. Because
Mm.
if we can teach AI to do that, to really understand what's important,
Yeah.
think about the possibilities. Imagine AI that can, like, sift through mountains of data and pull out those really meaningful insights, the kind that would take us humans, like, decades to uncover.
We're talking about like accelerating scientific discoveries,
Yeah.
optimizing these like crazy complex systems, maybe even cracking the code on things like personalized medicine or climate change solutions.
Exactly. All of that and more.
Mm,
It's really mind-boggling when you start to think about it.
it really is. So this research, it's not just giving us like a new tool for AI, it's giving us a whole new way of looking at it.
It's a new perspective, absolutely, because it's not just about building bigger and faster models anymore. It's about building smarter ones that learn and adapt more like living organisms do.
It's like we're moving beyond that brute force approach to AI, and we're starting to build something more elegant, more nuanced, and it all comes back to this idea that to really understand something, sometimes you need to forget.
It's a beautiful idea, isn't it?
It really is. This whole deep dive, it's given me so much to think about, and it
Mm.
seems like we're like right on the edge of this whole new era of AI. One that's not just about processing power, but about genuine understanding. And who knew? Maybe forgetting is the key to unlocking that. Thanks for joining us for this incredible journey into the world of selective attention. Until next time, keep those minds curious.